Hello everyone, and today we're going to uh, go to Unit 2, which is Equations and Inequalities. Before we go to the linear equations, linear inequalities, and compound inequalities, we're going to review the previous episode where I talk about introduction to inequalities. So, and also a little bit of interval notation. So, as if you remember, if we have a is less than x and is less than b, this is an exclusive, right? An exclusive inequality. As well as if you put a is greater than x is greater than b. How about a is less than or equals to x and x less than equals to b, as well as a is greater than equals to x and greater equals to b. This is called inclusive, where the values of a and b are in the um, group or the set. Inclusive inequality. Okay, so let me introduce you to our so the number line, the real number line. So the number line consists of every number: 0, -1, 1, 2, -2, and so on, negative infinity and positive infinity. I mean, you can also write the 1.5, the intervals, but generally we're gonna use the integers 3 and 4 and so on. So remember that if we have this inequality, which is the exclusive inequality, we have the open parentheses, a open bracket, a and b. Okay, if we have an inclusive inequality, we have a closed bracket, a and b. If it's partially exclusive and partially inclusive, it's either if it's a less than equals to x is less than b, or um, a is less than x is less than equals to b. That means this one would be close bracket a and open bracket b. So it doesn't include b. If this one, it's doesn't include a, but it includes b. Okay, so we can write this in the number line. So if we have 2 is less than x is less than equals to let's say um, it's only exclusive inequality 4. If you want to put it in a number line, we put a open circle. Let me down an open circle and drag along the axis and another open circle, and that denotes that it doesn't equals to 2 and it doesn't equals to 4, but it's between 2 and 4. So it'll be 2 and 4. Okay, how about, let's say, if we have 2 less than equals to x is less than, say, 5. So we have 5 here. 5. If there is an equal sign, we put a closed circle. So where's 2? So this is 2. Let's put it up here. 2 with a closed circle, and we go to 5, but with an open circle because it doesn't equals to 5. Okay, so this will be a closed bracket 2 and an open bracket 5. How about from, let's say I just give the interval notation, let's say from -2 2, 3, open bracket. So that means it's from -2, uh, the closed bracket, the closed circle, and to +3 with an open circle. Okay, so it's between those numbers, which is negative, but it equals -2, and it excludes 3. Okay, how about if I say -2 and let's say 1 with an open bracket union 1, and let's say union 2 to say 4, close bracket. So this means that if we have a union, so from -2, which is a closed circle, and to 1, which is an open circle, and we have union, so it uh, still in the um, range, or in the, what's it called, in the y level, from 2 but with an open circle, and to 4, which is both with a closed circle. Okay, but if it were to be like this, like -2, 1, union 1 to, let's say, 3, that means again -2 the same, go to 1, open bracket, and continues to our 3. But since it doesn't equals to 1, so the inequality has to have a split notation, which includes the union. Okay, so that's for the interval notation. Okay, now let's go through the linear equations. So linear equations, if we have an equation y equals to 2x plus 1 and y equals to 3x minus 1, notice that the values are the same, y and y is the same. So we can make these two equal also. So 2x plus 1 is equals to 3x minus 1. All right. So to solve this equation, we minus by 1 in both sides to get x in left side. Uh, we have 2x and equals to 3x minus 2. Now, to isolate x, remember that if you want to remove multiplication, we must divide by 2 on both sides. So if the coefficient is 2, so we have x equals to 3x minus 2 over 2. That implies that x equals to, if we split this, 3 over 2x, oops, yeah, yeah, 3 over 2x minus 1, which is 2 over 2, and this will be the same thing as x minus 3 over 2, x equals to -1, right? We multiply 2 on both sides here, minus 3 halves x equals to negative 1. That means negative x would be negative 1. So x must be 1. Okay. A faster way would be this, we times by 2 on both sides, which we get 2x equals to um, 3x minus 2. That implies if we minus 3x in both sides, we have minus x equals to negative 2. Yeah, this was for, oh, sorry, this was supposed to be okay. I noticed the mistake. X equals to 2. This is supposed to be negative 1 over 2. X equals to negative 1. Then x equals to 2 here. So that's for the equations. So if we have y equals to 2x plus 1 and y equals to 3x plus 1, 3x minus 1, we make them the same. Hence, we have x equals 2 as our solution. What does x equals to 2 means? That means if we plug in x equals to 2, then these values of y are the same. So let's prove it. If we call this y1 and we call this y2, y1 would be 2 times 2 plus 1, right? Then y2 would be what? 3 times 2 minus 1. That would be 5, and also 6 minus 1, which is 5. So y1 equals to y2 when x equals to 2. That's basically it for a linear equation. So that's it for the linear equation. Now we're going to inequalities. If we had negative 2 is less than x plus 1 is less than, say, not a compound inequality first. So negative 2 is less than x plus 1. That means if we minus 1, we treat this as a regular equation to solve for x. Negative 1, negative 1, negative 3 is less than x. Okay? So negative 3 is less than x. What does this mean? If we plot it in the number line with 0 at the middle, we have 1, negative 1, and negative 2, and negative 3. This means negative 3 is less than x. So x must be greater than negative 3, right? So we have an open circle at negative 3 and then to positive infinity. X must be greater than negative 3. How about 2x plus 3 is greater than 2? So 2x is greater than 2 minus 3, which is negative 1, and x is greater than negative a half. Okay, if x is greater than negative a half, if we put it in the number line 0, this would be negative a half, right? Approximately. Then an open circle, because there's no equal sign, to positive infinity. What is the interval notation for this? Which is negative 3 to positive infinity, right? For this one, it would be negative 1 over 2 a half to positive infinity. Okay, how about if we have 3x plus 2 is greater than 2x plus 1? Okay, in this case, first we need to solve the equation for x. Let's make x in the left side. So we minus by 2x on left and right. We have x plus 2 is greater than 1. So we have x is greater than minus 2 in both sides. We have negative 1. Okay, so x must be greater than negative 1. 0, 1, and negative 1. So it's greater. So it goes to positive infinity with open bracket and to positive infinity. How about 7x plus 3 is less than 5x minus 2? We minus 5x in both sides, which leaves us with 2x plus 3 is less than negative 2. That means 2x is less than minus 3 in both sides. We have minus 5. So x is less than minus 5 over 2, which will have x is less than negative 2.5. So in this case, we have 0, negative 1, negative 2, and this is approximately negative 2.5. So x is less than negative 2.5. So it will be an open bracket at negative 2.5 going to negative infinity. So the interval notation will be negative infinity to negative 2. Okay, how about we have a negative, let's say negative 3x plus 7 is less than 2x plus 1. We solve for x, we have minus 5x, and then plus by 7 is less than 1. So minus 5x is less than negative 6. Okay, if we multiply or times by a negative value, the inequality, the direction of inequality will change. So if we divide by negative 5 in both sides, we will have x is greater than negative 6 over negative 5 will be x greater than 6 over 5. So our inequality, the number line, would be 0, 1, and then what's 6 over 5? If we find it, it would be 1.2, right? Yeah, it's 1.2. So it's 1.2 here with an open bracket goes to positive. That's the solution for this inequality. Oh yeah, the interval notation will be 6 over 5 to positive infinity. Okay, how about compound inequalities? These are called, oh yeah, I forgot to say this, that these are called compound inequalities. And this also, and so on. So if we have a compound inequality, we split the inequality. So we have, let's say, a is less than x plus 2, and also x is plus 2 is less than b. So we split the inequality into a singular inequality. So we would have a minus 2 would be less than x, and also x plus 2, x would be less than b minus 2. So in this case, let's say we have negative 2 less than x plus 1 is less than equals to, say, 3. So if we minus 1, so first thing, we can actually do it as a whole. So calculate it as a whole. So while treating it as an equation. So if we minus 1 in the middle, that means we have to minus 1 in the left and right. So if we minus 1, this will be minus 1, and this will also be minus 1. So we have minus 3 is less than, x is less than or equals to 2. So our equation will be x in between -3 and equals or less than equals to 2. So the inequality, the number line would be 0. This is -3, let's say, and this is +2. So the solution will be in between an open circle at the -3 and then a closed circle at 2. Okay. Again, if we split it, let's say -2 is less than x plus 1, and also this is called and um, x plus 1 is less than equals to 3. So -3 is less than x, and x is less than equals to 2. So -3 is less than x, that means x must be greater than -3. So the same, greater than -3 but less than or equals to 2. And the range or the interval notation would be the would be from 2 -3 open bracket to 2. Sorry, this is not the range. Okay, how about if we have -5 is less than equals to -2x plus 3 is less than 1, right? So -3 minus 8 is less than equals to -2x, and this one would be -2. We divide by a negative, that means we flip the inequality sign in a different direction. This will be -4 is greater or equals to, oh sorry, +4 x, and is greater than 1. So if we plot this in the number line, x -4 4 it must be greater or equals to x. So this is equivalent to 1 is less than x and is less than equals to 4. So we have 1 here and 4 here. So we have an open circle and a closed circle at 4. Our interval notation would be 1 and 4 with a closed bracket. Okay. How about if we have like a compound inequality, 2x plus 1 is less than equals to 3x minus 1 is less than, let's say, 2. In this case, we have to split the inequalities to singular ones. So 2x plus 1 is less than equals to 3x minus 1, and also 3x minus 1 is less than 2. Minus x, so we minus 3x in both sides. We have minus x plus 1 is less than equals to -1. So minus x minus 1 both sides will be -2, and we divide by negative, so the inequality will change direction. X is larger or equal to 2. For this one, we add 1 in both sides. 3x is less than 3, so x is less than 1. So if we plug it in the number line, x must be less than 1, but x must be greater or equals to 2. So if it's less than 1, it will be here. If it's greater or equals to 2, it will be here. Oh look, there's a split here. That means we need to use union. So from positive negative infinity, right, since x is less than 1 to 1, union with a closed bracket because it's equals to 2, but and it's greater or equals to 2, so to positive infinity. So this is the interval, the solutions of x. Okay, and last example for compound inequalities would be, say we have 3x minus 2 is less than equals to 1 over x is less than 2x plus 1. Oh no, let's say it was like this. 5. So in this case, we times x in everything. So 2x is less than equals to 1, less than 5. That means x, yeah, we split inequality. So 2x is less than equals to 1, or, and this is the notation for n, x 1 is less than 5x. So 2x is less than equals to 1, so x is less than equals to a half, or n, um, 1 over 5 is less than x, or you can say it's equivalent to x is greater than 1 over 5. So if you put it in the number line, this will be 0, and x would be less than equals to a half, but x is greater than 1 over 5. So what's 1 over 5? That would be 0.2, right? So x must be greater than 0.2, or x is less than equals to 0.5. So let's say this one was 0.2 and was 0.5. So it's greater than 0.2, then it's less than equals to 0.5. So if a close bracket. So the interval would be 0.2, and let's put comma, or let's just use fractions. 1 over 5 is and what's this, a half, with a close bracket. Okay, that's it for this video. I hope you enjoyed this video, and I think I will talk about more inequalities, especially in quadratic inequalities, rational inequalities in future episodes, but still in this unit, of course. So thank you. Hope to see you on the next episode.